Understanding basic principles allows for intuition and reasoning to control the learning process. Often students become frustrated with math because they haven't developed the necessary insight supporting the logical step-by-step progression that is commonly left out in the textbooks and lectures. Although the equation of a straight line may be familiar, the ability to plug in numbers to manufacture results does not establish understanding. Hence, the purpose of this video is to teach understanding. Let's start with the concept of distance between 2 points on a line, designated by the symbol delta. The origin necessarily establishes the reference point from where it is possible to designate various magnitudes. The basic concept is to subtract the shorter length from the greater length. In this case, x2 is the greater length. Consequently, when the magnitudes of x1 is subtracted from the magnitude of x2, we get the distance between x1 and x2 represented as delta x. When a set of causal measurements are derived from a linearly behaving system, they can be used to construct a function in a rectangular coordinate system where the horizontal x-axis consists of the independent values and the vertical y-axis consists of the dependent variables. Our objective is to clearly demonstrate that two such sets of values are sufficient to plot 2 points in our rectangular coordinate system, and these points can be connected with a straight line. The straight line uniquely relates each x value to the y value, and the equation that describes this line must do so uniquely. Now that we have a line plotted on our rectangular coordinate system, let's consider how we might construct a function for this line that will relate each x value on the x coordinate to a unique y value. Let's start by defining the slope of a line. The slope of a line is a ratio which is determined by dividing delta y, or the rise of the line, by delta x, or the run of the line. Note that the rise and run form a right triangle with our line, and any other set of 2 points will form a similar triangle with the same ratio, which we call the slope. However, knowing the slope will not uniquely define a line, since there are an infinite number of lines with the same slope as illustrated by their parallel lines. Therefore, an additional criterion must be established. Consider the y-intercept, noting that it will not satisfy the uniqueness of the line by itself. This can be demonstrated by drawing several lines through a single y-intercept. When the y-intercept of a line is combined with the corresponding slope, only one line can emerge. Hence, it seems reasonable that the derivation of the equation of a straight line should necessarily include both the slope and the y-intercept. It remains to be shown that the values of slope and the y-intercept can be used to formulate an equation that uniquely describes a line. Consider our line again, plotted in a rectangular coordinate system with its slope determined by delta x prime and delta y prime. We know that choosing any other 2 points on the line will result in the same value for the slope designated by the symbol m, due to the properties of similar triangles. Now let's choose 2 values on the x-coordinate with x1 assigned the origin. The origin is chosen because this choice for x1 will cause x2 to take on the delta x value, since x2 minus 0 is equal to x2, which of course equals delta x. Grasping the significance of this insight will greatly improve your understanding. So the coordinates for the first point is given by 0 and y1, and the coordinates for the second point is x2 and y2. It should be apparent that delta y, which is equal to y2 minus y1, when divided by delta x, which is equal to x2 minus 0, is the slope of our line. A closer examination of the significance of delta x, which is equal to x2 minus 0, shows that delta x is equal to x2, which can take on any value along the x-axis. Therefore, delta x can simply be represented by x. Hence, multiplying the slope of a line by an arbitrary x is equivalent to multiplying the slope by delta x, which will always equal delta y. Note that the sum of delta y and y1 is equal to y2, or the value we want to associate x to. So we can write a valid equation for the values of y2, which states that y2 is equal to the slope times x plus y1. So the value of y2 represents the sum of delta y and the magnitude of y1. And let's be clear, delta x has the same magnitude as x2 with the restriction that x1 is the origin. Consequently, making y1 equal to the point where our line intersects the y coordinate, which is identified as the y-intercept. The symbol B represents the y-intercept. Now, putting these pieces together, we can formulate the equation of a straight line, which is a function of x. Therefore, the value of y is calculated when x is multiplied by the slope and then added to the y-intercept. So y2 equal to delta y plus y1 is written as y equal to mx plus b.